This is pre-sum map. So please write pre-sum. Plus 1. That's j minus I plus 1. Very simple maths. J minus I, because this, and then I iterated the entire sub whose k fixed. One subarray is this, who will have this dot as the last element. The other one is this, who will have the dot element as the last. The other one is this, because the dot element is not there. I need the dot element to be the last. I cannot even say this because the dot element is not the last element. Dot is the last element. So I will use. Can I say if I'm standing here and I say summation to 1, the summation is 1, and that's not equivalent to 3. So you take 1 and you say it occurred at index 0. Probably I'll write the index for better understanding. So 1 occurred at index 0 and done. Next, move the pointer 2. Summation increases to 3. Summation increases to 3, which is equivalent to k, which is equivalent to k. So what you say is, okay, wait, this entire prefix sum is equivalent to the k. That means this in itself is an array or a subarray who is giving me this sum. So if the subarray is till index 1, so the length will be 2. 0 based indexing, so the length will be 2. Perfect. And at the same time, say you got 3 till here, which is index 1. Perfect. Let's move. You got 3 now. You got 3. The summation will be 6. The prefix summation is 6. The prefix summation is 6. Now comes the twist. So 3 elements, and till now the prefix sum is 6. And you're looking for someone with 3, and that someone is this. So if this is 3, I did a reverse engineering. The remaining was 3. I said, hey, wait, did we get some 3 before? And he says, yes, till index 1 you got a 3. That means this subarray, there does exist a subarray with a k. Reverse. So what I'll do is, I'll say, till it is 6 now, you need 3 now. 6 minus 3 is 3 now. Look from the front. Is there a 3? He says, till 1 there is 3. Till 1 there is a 3. So I'm getting a subarray. You're standing at 2. Till 1 there is a 3. So 2 minus 1. So the length of that subarray is 1. The length of that subarray is 1. But that's not greater than 2, so you'll not do anything. So 6 comma 2. Perfect. Let's go. You got 1. 7 is the new sum. So what can I say? I have 4 elements. And the prefix sum of this is 7. What am I looking for? 3. For someone to be 3, someone from the start has to be 4. Do we have someone from the start as 4? No. So did not find. Take the 7 and put it at index. How much is that? 3. Perfect. And now let's move. When you move ahead, you get 8. So when you're getting 8, which means you're having 5 elements. And again, right, you're having 5 elements. It is having 8. So for someone to be 3, someone has to be 5. Is there someone with 5? No. So just put 8, comma 4 and move. Next, you move ahead. So that's 9. So there are now 6 elements. 6 elements are giving a summation of 9. 6 elements are giving you a summation. So for someone to be 3, someone has to be 6. And I get a 6. I get a 6 at index 2. So this is 6. So these many remaining will be 3. So you're currently at 5. Till 2 there was 3. So the subtraction, the length is 3. So you got a better one. So this is how you can go ahead and you can figure out if someone was there in the back. This is what I will call as a better question. So you're given the vector and you're given the k. Something important. important to notice is it is given as long. First declare the map. So map will be long because that is where we will store the prefix sum. So you can say pre-map, pre-sum map or something like this. Perfect, done. Now what I'll do is I'll go across the entire array, which is something like a.size. So let's go across the entire array. Now what I'll do is I'll declare sum, and again please take long. And over here I'll also take a length as 0. And at the end of the day I can say return length, or this can be max length to have better naming. So I can take max length. Over here I'll say sum plus equal to a of I. And remember, initially always check if the array from start till the current index is giving you k. If it is giving you, then the max length will always be max length comma I plus 1. It will always be like. Even if you do not write max, it will work, because if you add I, that's always the maximum. If that's the case, that's perfect. What can be the other case? I'm looking for remaining. Bring the reverse mathematics. How much do I require? This is what I require. So if my map has this remaining, which means it will not be pointing to the end. So remember, this is pre-sum map. So please write pre-sum map dot end. If it does exist, that means it does. So thereby, what is the length of the sum array? Can you say the length of this will be I minus pre-sum map of the remaining wherever it is, and then you can do a say max length equal to max length, comma length. Right at the end of the day, whatever sum you have generated is a pre-sum map. Is a pre-sum map of this particular sum is equal to I. Something to ponder over here, like this. If I try to submit this, this will run. There's a slight edge case that I want to talk about. This code that we have written, is that correct? That is correct, but only for positives. If I tell you that the array has that I want to talk about, or this code that we have written. Is that correct? That is correct, but only only for positives. If I tell you that the array has zeros, the code that you have written will be wrong. Why? Let's understand that by an example. So imagine I take an array which has something like 2, 0, 0, 3. I'm looking for a summation of 3. That's what I'm looking for. How does it work? It's very simple. We take a prefix sum, we give a pointer here, we have a hash map, right? And then we have a length as 0 initially and prefix sum as 0. Let's start the operation. When we are 2, which is index 0, we do the prefix sum as 2. And we say, this is 2, is that equivalent to this? That's not. We know one element is 2, so is there any one previous? No, so that's fine. And then we go across and say the hash map 2 occurs at index 0. Done. Next we move. How much is it? 0. So 2 plus 0 will still be 2. So till here we have 2 again. And that's not equivalent to 3. And 2 elements are having 2, which is this. So for this to have 3, someone has to have -1, which is not possible. 3. So okay, fine. But till here, it is again having 2. So the hash map this time replaces to 2, 1. Then we move. Again 0. 2 plus 0. Again 2. Hash map this time represents to 2, 2. So erase this. It'll be 2, 2. Now, next when I go here, it becomes 5. And it's like 4 elements are having 5, which is not 3. How much am I looking for? I'm looking for 3. So I need someone with a sum 2. I need someone with a sum 2. And when I look at the hash map, it says till here the summation is 2, which is correct. So thereby, this much is the subarray, which is again correct. But we need longest. We do not need shortest. We need longest. So apparently, we should have just stored 2 for index 0. And this subarray 0, 0, 3 would have been the answer for longest. Thereby, if a sum previously does exist, you should not re-update. Because if there is something like this, and this one has a summation of x, and you're looking for k, you'll try to look as left as possible for x minus k. You'll try to look as left as possible for x minus k. Did you get this? I hope you did get this. Because you'll try to look for the leftmost guy for the sum of 2. Because sum of 2 is here, here, and here. But you take the leftmost so that you get the longest summary. This is where it will fail. So there is a slight change in the code that you have to do. So if I go back to the code, this line will be inside braces. And if you're putting that into the map, what will you write? You will say, okay, wait, what's the map's name? This dot find was the sum previously not there. If it was not there previously, then I will go ahead and say, okay, cool, that was not there, so I'll just put it. So it's a minor change, by the way. Looks like, okay, sorry, my bad. Okay, should be good. And let's just format this. Perfect. Now let's quickly run this and see if it's running by. So what did I say? If it does exist, I will not. And now I will go and submit this, and this will be running. Oh, it did not. Why? Also, you've got to change this to this one as a summation of x, and you're looking for k. You'll try to look as left as possible for x minus k, you'll try to look as left as possible for x minus k. Did you get this? I hope you did get this, because you'll try to look for the leftmost guy for the sum of 2, because sum of 2 is here, here and here, but you take the leftmost so that you get the longest subarray. This is where it will fail. So there is a slight change in the code that you have to do. So if I go back to the code, this line will be inside braces, and if you're putting that into the map, what will you write? You will say, okay, wait, what's the map name? This dot find, was the sum previously not there? If it was not there previously, then I will go ahead and say, okay, cool, that was not there, so I'll just put it. So it's a minor change, by the way. Looks like, okay, sorry, my bad. Okay, should be good. And let's just format this. Oh, perfect. Now let's quickly run this and see if it's running. So what did I say? If it does exist, I will not. And now I will go and submit this, and this will be running. Oh, it did not. Why? Also, you've got to change this to long, and now you can go ahead and submit this. This should be running fine. Yeah, it does. So I hope you've understood how do we cover the edge case. And the same code will also run if it has negatives. Because in the negative, we apply the same logic, and it does run. If you observe, this particular code is partially accepted. Why? Because this was the better solution that we were discussing. We still need to optimize this. But this same code will work for a problem that has positives and negatives in the array. Because in that case, the better one for that was not there, so I'll just put it. So it's a minor change, by the way. Looks like, okay, sorry. Not bad. Okay, should be good.
Big move on a torture.